All right, thank you to the Startup Roundtable. We just some logistics. After this, after I finish my presentation, we will be headed across the street to Bear Burger. For those of you here, obviously, for drinks, open bar, snacks, whatever. So that's where the real fun starts. But to get through this event, and you know, the speakers were unbelievable. And I will say, it's funny how this event sort of transpires every year. We just get really smart people and really talented people to come up and speak. And somehow there's a theme that comes out of it. And we didn't plan it. Like that was these group of speakers, we just said, we know these guys or these people, they're super smart, they're talented, they're leaders in the industry. Let's just get them in front of here and they'll say smart things and we'll learn from it. So, you know, we look good from putting this together, but it's really just people that we have to invite. So just to wrap this up a little bit, I have to thank Dave Mans and JC who put together this. This event is I will say is like an orchestration, and we meet every single week, and we plan minute by minute. Doesn't always work out that way, but we do that. And logistics of such an event, from the workshops to the symposium to the hackathon to whatever happens, is actually incredibly difficult. And but it's also super satisfying as well. So. To that, these people have a, you know, huge thanks to these people. Dave and JC, and there's been others, so I you know, I don't want to leave everybody else out, but these were the main folks. Big thanks to the workshop masterclass presenters. You know, I was listening, you know, from we had Core Studio folks like listen to every single one just to make sure someone hit the record button each time. That's always, everyone forgets. But I was looking at the machine and hearing the background feedback, and you know, the learning that goes on and the teaching and the learning is incredible. I mean, I think that's probably the most important aspect of this event, is that people that come here, they walk away a lot smarter and a lot more informed about the industry and potentially even their careers. After this. So I think that this is a huge part of it, these master classes. And you know, these people, even preparing for these events, have hours and hours and hours go into putting together a day-long workshop. Trust me, I got shingles because of that one time. So anyway, literally, so I got my shingles vaccine. Anyway, and of course I just mentioned the speakers. You know, can't thank them enough for coming here from all over the place. You know, the people here are just super smart, have a ton of experience, and have a ton to share. The sponsors, again, I feel like people that put their time together to put these workshops, they're really sponsors, and as well as Skanska, who's sponsoring the drinks and get together across the street. Of course, you know, Rhinos are in the center there. We always appreciate their contribution, not only to this event, but to the industry as a whole. And yeah. So a little bit about, you know, Core Studio and AECtech, and we've been doing this, again, for 9 years. Next year will be our 10th, so we'll do something special. But actually, Mustafa actually went to the first hackathon, which was the AECtech hackathon that's done. I think now they do it in Copenhagen. But the first one was in 2013 at the Facebook headquarters. And I saw the look on everyone's face who did go. It was like, I think it was Mustafa, it was Jonathan Schumacher, and there was Ben House, and I think it was Kenny Tam and Daniel Seagrave. So those folks went, and I just saw the excitement in their eyes of like, holy crap, like there was something called the web, right? Like we had no web tools. And so that's when we started. One, the hackathon thing was when we started our own. And then two, we started building web tools after that. So that's why all of our, engineering as a web service started in 2013 at a hackathon. So just to get to the team, there's an incredible team here, super diverse background of skill and talent. And we've sort of, we don't necessarily, sort of figure out a skill set that we necessarily need. Again, my approach is, if you get really, really smart people who are passionate about what they do, something great will come out of it. And so, great team. Badri's still in the picture. He's done a ton of work with us, and since he's been in Core Studio. So best of luck to TTD2 and that team. I had this slide last year. I added one category here at the end, which was the transparency part. But this is what AECtech is all about. Share technology, learning new things, computation, data. We heard about data the whole time here. The shared future, I think we're hearing about that as well as the transparency across firms, across entities, across tech. I think that's huge for our industry. I just want to touch, this is a little bit of an expanse on what Ben had talked about of engineering as a web service. And we've kind of been, I would say, researching this for many, many years. And we've kind of come to a conclusion of path forward for what augmented automation means. And I have to give props to Charlie Cortelli, who we used to say always automation because it sounds cool, but it's not really true. It's augmented automation. And we'll probably never get the full automation. Again, 2018, we released this. We started this app in 2016, took 2 years to do. Machine learning is really, really hard. And we learned a ton from this. There's still nothing else in the industry that does this, designs a building in under a minute. But we did learn a couple of things. One, machine learning models have to be tuned to how engineers think and what the results they're expecting. The machine learning models in this app use code-based algorithms, which means that they are right, except that there's not a building design in the world that is exactly designed to code. It's usually 20 to 30% over. So the engineers saw the results and were like, I would never do that. I would never size that column for that way, whatever. So the other thing is, it was very black box, right? It was like, they don't know what's behind the curtain of this thing. It's doing amazing things, still does, but they didn't know what was behind it. So the trust was not there. And the other thing is, what the app was, the problem with this was, the models are locked into the app. We couldn't reuse that, tune those models. So we were kind of stuck with what we had. And there's a lot of technical debt that goes into building these web apps. So, fast forward a couple of years, we built Swarm, which is now sort of partnered with Shapediver. This is our Timber app. Ben mentioned Core Structure. Core Structure for Timber is actually embedded in this app here that has Grasshopper operating in the background as well as Rhino. But we built Swarm not because we wanted necessarily just Rhino in the background. We actually wanted a very fast way to deploy apps. And that it was mentioned kind of here today that the future of app building is going to be very bespoke. I make the analogy to, like, if you're gonna bake a pie, an apple pie, there is a very specific recipe to that apple pie. And our industry is like, everyone makes a different apple pie. And so therefore, we're gonna need very bespoke models, whether it's AI or whether it's an API that calls some core algorithm, that sort of we can fine tune for the very specific projects. So this is kind of how diagrammatically that has looked in terms of the aggregating the engineers' intelligence, the methods that they use to do a single task. And again, this is like, A through F. This is A through, Z's and double A's and everything else. So this is what we're doing now. We're sort of aggregating those apps that are built for speed, or those processes, and those processes that are built for accuracy. We need both, because we in early design, we need speed. In the later projects of time, we need accuracy. So core structure is essentially this. We are codifying every single equation, or not every single equation, the key equations in all of these design codes, such that we can call them at any particular, for any particular flavor of pie, if you will, app, to be used later. And our guys are being very smart about this, is that we want them to be queryable. We want to know exactly what element, if we're designing a beam, say, why that beam used this particular code base, and what equation that used with that applies to that code base. So basically the calculation becomes an attribute of that particular element. And that is necessary to sort of automate the reporting process, quality control process, as well as, like the design and manufacturing process. You need that full chain of the input parameter all the way down to the final solution. So this is an example of this. This is we started in 2016. Our Skipper beam design app is like a video game, which why many people like it, but it's also CD level accurate, down to the very sensitive vibration, which doesn't actually exist in any other app. So we've built in the intelligence, again, of like the smartest folks in our office to have an app that does CD level sort of parametric design for a bay in seconds. And we also have a way, if you wait for it, to print out that full report of that particular design. So that's sort of the accuracy piece. And then we're building these bespoke machine learning models. And I will say it's very difficult. Produce the data necessary to train a reliable model that people can use. I feel like just like in, let's say, a Tesla car, right, that's doing autonomous driving, that has 3 controls. It's got the steering wheel, it's got the 2 pedals. There are thousands of machine learning models built into there that sort of have to, take a series of inputs, predict what the pedals and the steering wheel does. Ours is a little bit, in many ways, potentially even more complicated, but it's the same concept where there's going to be not just an app that does a building design, it's going to be a series of apps, micro apps, if you will. And it's going to be a combination of synthetic generated data as well as project data from past projects. And so it's going to be a combination of both the accuracy and the speed that gets us to the end game. Whoops. Okay. There you go. So this is something we did over the summer. And what this is showing is the comparison of the ML, the red line, and the physics-based predictions of this brace frame that we're designing, which is sort of upping the game of element-based machine learning to assembly-based machine learning. So I don't want the sound. So anyway, this validates kind of what we're doing. So just as an example, a reason why I say it's hard, machine learning is hard, is a single beam, composite beam designed in a building. I had an intern coming this summer help us out. He was an incredibly smart guy, but he never designed a building in his life. So what he did was he set up the model, set up the sort of physics-based model to create the synthetic data. We ended up with 4 billion possible data points. And so this is where the sort of institutional knowledge comes into play. I took most of those inputs and just cut them out. I was like, that's not even going to have any difference to the end result. it's not a real sort of variable in a project, and let's cut it out. And so there's an optimization level when you're creating synthetic data for machine learning. So some of you may know Construe. I'm not going to go through it. It's basically an app that we developed that is a data schema for BIM that sort of talks natively to all these other different applications, specifically from a data model, from a central model. And again, we've been working on it since 2012, so it's come a long way. And last winter, I did a little internal hackathon of like, okay, Construe is essentially by definition a structured data set. So can I take the structured data set, parse it in a way that I can create a data set, a machine learning model from that particular data set? And so I took this single Construe model, which is the VIA West 57th Street, designed by Big, and that we were the engineers for. And we had all the sort of, full, engineering model in there. And I just looked at one element, which was the columns. And it's a pretty decent sized building. It has over 3,000 columns in it. And I was able to take that single model to create a single BIM model and create a machine learning model for the columns with a reasonable accuracy. So that proved out that it's possible to take a BIM model, parse it in a structured way to create machine learning models. So that's what we want to do in the future, is to take past projects, parse it in a way that we can get it to be trained for machine learning, and then have models that we can predict something like this. So if we come with sticks and wireframes, use those same models, predict the building. So that's the speed aspect. And then we realized also from Asterisk 1, that it's hard to get those models sort of reusable in other applications. We did it with test fit, but it was not a trivial task. So we wanted to create a platform that sort of houses all of this workflow of data set creation, model training, model deployment. And so Sergey and Runal and Liddy have been working on this, and Rishikesh, been working on this for a while now. What this allows us to do is, think of it as like, well, there's nothing equivalent to it. The first part of it anyway is like File Explorer for data. So we're gonna have these huge data sets for the models, but then we also have we're gonna have a series of runs, because if you're doing machine learning model, you're using multiple algorithms, you have to check all your accuracy, change hyperparameters, et cetera, et cetera. So you're gonna have a bunch of these runs, and then we're gonna promote the ones that we want into this app, and then we have a way to create a simple API key for an app. So we'll have eventually basically a marketplace, if you will, of machine learning models to be used on an API by API basis. And so we're getting there very quickly. So my prediction for 2022, and this is a challenge for us, but and the team, is that what I want to do is have a design development level automated automation process by next year in minutes. And for those of you who are not familiar with the terminology, design development is like 40% of our fee as engineers and architects. And it basically produces a sort of almost design building, like a 30%, 40% design building. And if we can get enough sort of core structure, code-based machine learning models, we can start to do that. So that's it. Actually, that's my presentation. So that's a challenge for us for next year. Now, adoption is going to be a different story in the office, but that's okay. That's part of the process. That's part of working out sort of the bugs is in sort of like the UI of these things, and also the trust of these platforms. So again, I'd like to thank everyone who's come out today, everyone who's online. all the speakers and the workshop presenters. And I hope everyone comes to the hackathon, even if you're not going to be hacking. So that's going to be at our offices starting tomorrow morning at 9 a.m. at 120 Broadway. And we have prizes, cash prizes, as well as we have a really incredible jury. So I'm gonna hope I get everyone correctly. We have Sean Gallifer and Diloshka Video Renfro. We have I'm blanking now. Alex Pollack from FX Collaborative. We have Corey Brugger from CTO of HKS. We have Jason Lee, who's the chairperson at Pratt Institute. And I'm missing one other. Cecile Brandt Olsen, who is a phenomenal technologist and structural engineer with their own firm in Copenhagen. So they're going to be the jury for the hackathon this weekend, and hope to see you all there. Thanks all.